Hello, guys. So today we are here after a while, you know, we are here to solve this problem. And I know I have been, off for a long time, but when you are stuck with this, uh, problem solving bug, then you can't keep away from it for too long. So you have to, come back to it and do it again and again to get that thrill. So we are here to solve this problem called maximum distance in arrays. Okay. And in this, we have been given a list of integer, which is named as arrays. Even though it is list of integer, it is named as arrays. Okay. And this arrays contains m arrays. Okay. The list contains m lists. Okay. And each list is sorted in ascending order. Okay. And so the smallest element is at the first index and the largest element is at the last index of each list. Okay. So each list individually is sorted and the smallest of that particular list, if it is sorted, then we already know that it is at the 0th index, and the largest of that list, if it is sorted, then it is at the last index. Okay. And then we have to pick two integers from two different arrays. So this point that has to be noted is that we have to pick two different integers from two different arrays. Okay. So this is the main thing here. Okay. Two different arrays. Okay. And each array picks one. Okay. So from each array, we can either pick the smallest, or from the each array, we can pick either the largest. Okay. And then we have to calculate the distance. And by distance, what do we mean? The modulus of a minus b. So if a is the max and b is the smallest, then we are taking this modulus of a minus b. And after doing this, successively, we have to find the maximum distance. So what is the maximum possible distance between the maximum from one list and the minimum from another list? Maximum and minimum cannot be taken from the same list. So this is the constraint of this problem. Now to solve this problem, what we can do here. So when I first saw this problem, I thought, maybe I'll do it like this. So I'll take it, list of integer and I'll just sort it. Sorted list is equal to arrays dot stream. Okay. Arrays dot stream. And then once we get this stream, then we can call flat map. And inside the flat map, we take the individual list. So the individual list, and on that individual list, we call the stream. So this will return the stream of the individual list to the flat map, and flat map will take and flatten it out. And after it flatten it out, so we'll be sorting that. And after sorting it, what we'll be doing, we'll be collecting it to a list. And to collect it to a list, we'll be doing collectors.toList, and that will be stored in this sorted list. Okay. Now, what I felt that if I do it like this, see, sorted list dot get sorted list dot size -1 minus sorted list dot get of 0. So 0 is the smallest element of that list. And if we do it like this, we'll be getting the maximum distance. But the flaw in this, that this smallest and this largest, they might come from the same list. And this is the flaw that we can observe. So if I run this, it may even pass the sample test cases. Yes, it's passing the sample test cases. Okay. So it's passing this test case and this test case. Okay. But suppose if I create a test case, can I not create the test case? I think I can create the test case. So if I create this test case, in this, what I'll do, that I'll put the largest also in this. So largest is coming from this. So let's say largest is 10. And then the smallest also I'll put in this list only as 0. Okay, so if I run this, oh, it should be like this. Remember, the array has to be sorted. Okay, so we'll do it like this. Now we'll run. So see, this is coming as wrong because 10 minus 0 is 0, but they are coming from the same list. It will be returning 10 minus 1. It will be 9. It is expecting 9, but we are returning 10 minus 0 because 0 is the minimum overall minimum and 10 is the overall maximum, global maximum, and 10 minus 0 is 10. But according to the problem constraints, we take if we take the maximum from this list, then we have to take the minimum from either this list or this list, and minimum from these two lists is 1. So this approach is not going to work. Okay, now to solve this, we have to come up with a different strategy. Okay, so let me get rid of this code, even though it looks beautiful and elegant. But as we all know, if it is worthless, then we can't do much. So what we'll do that, we will take this arrays dot size. This will be the size, and then arrays dot size we took, and now we will take max diff, because we want this maximum distance. We are max distance, we can call it maximum distance, and it will be -1 because this is what we have to return. Okay, and we can also take previous min. We can take it as previous min is equal to, so to get the previous min, what we have to do, that we have to take the first list. So list of integer, and first list is equal to arrays dot get of 0. So this will be giving us the first list, and previous min is going to be first list dot get of 0, because the list is sorted. Every constituent of this arrays list, it is sorted. And previous max, so this will be first list dot get first list dot size -1, like this it will come. Now we have got it. Arrays dot size max distance is equal to -1 previous min get 0. All these things are fine. Now what we will do, that we will go through this list. So for int, we have got the previous, so already that first thing is considered. Now we'll go through from first index to the last index, and we'll do plus plus I. And then what we will do, that we will get the list at that particular index. So this list is arrays dot get of I. Okay. So once we have get this list, we can get the current min, which is list dot get 0, obviously, because it is a sorted list. Every list in this given arrays is a sorted list. So the minimum will be at the smallest index, I mean to say at the 0th index, and maximum will be at the last index of the list. So once we get this, what we will do? So once we got this, now we have previous min and previous max. So we can check what is the maximum distance between max distance is equal to math.max of max distance, and we have the previous max. So remember, we have to take max from the other list and min from the any other list. So we will be considering the max from the previous list and the min from the current list. Okay, current list. So current list is current min. Okay, and then we will check which one is greater, and then we will, we can update after we have used this max. We can update this max with the next, when the next iteration of this loop, we can again update this previous max with the current max. So I mean to say, when we go to the next iteration, so at the first iteration, uh, the current max and the max of the zeroth index is considered. But for the second iteration, uh, the max of the zeroth index and the max of the first index, they will be compared, which are these two values, and they'll be considered compared and stored in the previous max value. So for second, this is the previous max value. And then again will be, the other max can be between current max and previous min. Okay. So here we have compared previous max and current min. Now we'll be comparing current max and previous min. So max distance again will be this comparison, math.max max distance, and here we'll be taking current max minus previous min. Now, once we have used this previous min, we are free to update this min as well. And how to update this previous min? Previous min, current min. Okay, like this. And then we can return this max diff like this. So once we have done this, this is the simple way to solve this problem. This is the simple way to solve this problem. So before I claim that this is a simple way, let me first run this so that I convince you that this is solving this problem. So sample test cases, let's check the sample test cases. Okay, so there is some max distance is the name of the variable, correct? So we have to use max distance only. Max diff is not valid name for this problem. So we have to use max distance, and see all the sample test cases are passing. If we want, we can create some other, sample test cases. So what we can do, let me see, 9 is expected. If I put 0 over here, okay, in this test case, if I copy this test case and put 0 over here, then now it should return 10, because this is 10 is coming from this, so which is the global max, and 0 is the minimum. And why only this? We can take minus 10 here, and minus 20 here. Okay, and let's see what result we are getting. Let's see. So for the case 4, 10 and minus 10, it's 20. Oh, minus 20. And then the maximum is 3. So it's minus 23. Perfect. Perfect. So if I put here, mm, 20, then it should be giving us 40, and this should not be, this should be 25. Okay. Perfect. So it's giving us 40 because minus 20 and this 20 is giving us 40, and this 25 is not being considered. Okay. But if I put here 46 instead of this, if I put here 46, 49, okay, 49 minus 3, 49 minus 1 will be 48. 49 minus 10, it will be 59. Yeah, so then it will be 59. Yeah, this answer is 59. Perfect. So we are confident that this approach is going to solve this problem. We'll submit this. Perfect. So this is what this problem is submitting, solving this problem. Thank you. So with this, we can end this video. Thanks a lot.